Hi everyone, and welcome to Sweet Streams Are Made of These, data and metrics-driven development for stream processing. My name is Caito Scherr. I am a developer advocate. I represent the US region for Ververica, the creators of Apache Flink, and I'm based in Portland, Oregon. I used to be a software engineer at a data analytics company, and I've been doing stream processing with Flink since 2017. So combining metrics and stream processing is one of my favorite things, so I'm very excited to talk to you all about that today. And in these weird virtual times, I want to be extra clear about how to get a hold of me. So if you have any questions about Flink or stream processing or just want to geek out about it, I promise I'm friendly and I really do love talking about this stuff. So feel free to reach out to me over Twitter or email. A warning about my Twitter account is it is mostly stream processing, but be prepared for some photos of my dog and the occasional or actually pretty frequent really bad pun. And with that, so agenda today is that firstly, data-driven development can mean a lot of different things. So I want to start with some basic principles that I'll be covering in this talk, as well as a brief overview of which challenges this relates to for stateful stream processing specifically. Next, where to even get started? How do you know what to measure? What's going to be the most useful thing to you to measure? And how do you figure all that out without spending a lot of time and energy on it? So I jokingly, but also seriously, call this metrics-driven metrics. And you'll see why I call that later. So that's going to be the bulk of the story today. And then lastly, a bit about the fact that stream processing just has a lot of additional challenges and how it impacts the surrounding ecosystem that are just sort of unavoidable. So I think it's really important to end with some metrics about where those integration points come into play and using metrics as a shared language to minimize some of those challenges. And a couple notes before we start. So this talk is really about applying data-driven concepts to Flink and other stream processing development processes. So although I'll be talking a lot about metrics, this is not going to be a tutorial or like a step-by-step getting started, because there's really already a lot of those out there, and there's some really great ones, and they're pretty easy to follow. So I've linked to a couple of those resources at the end if you're interested. And additionally, I think it's really important for systems to be provider agnostic when it comes to metrics, because really if the product that logs, tracks, analyzes, or alerts in your data goes down, it would probably be pretty nice to have a backup system. So maybe you have like a JSON API that you can query that's just part of your system. So if the worst happens, you have redundancy in your monitoring and logging as well. So for this reason, I'm going to try to keep myself provider agnostic for this talk as well. So you'll see metrics from a whole variety of different monitoring and alerting providers. And a side note about that too. So many developers that use the dashboard UI that comes with Flink. And for me, when I first started with Flink, this was a huge selling point for a reason. And I do still recommend though pairing this with other observability providers. So at my last company, we used the Flink UI almost exclusively for all of our job tracking, task management, task managers, and any other elements related to the status of the application. But Flink already has a REST API integration as well, so this makes being provider agnostic a lot easier if you're working in Flink. So I've included a couple examples here from the current 1.11 release. So this is some of the main available default categories, like requesting metrics for a specific entity, aggregated metrics by type, either for all entities or for a subset. And then on top of that, Flink also has reporters for some of the more popular external observability providers like Datadog and Prometheus. So all of that just makes it even that much easier. So there's, again, some really great documentation and talks on this already. So that's one of the reasons I won't be covering this as in depth, and I'll be linking to those at the end as well. But they're cool enough, I really want to make sure and give them a good shout out in the beginning here. So briefly, I want to cover some of these data-driven basics and how I'm going to be using some of these terms. So if you Google the title of my talk, maybe not the pun version, but the subtitle, you probably notice that there's a lot of terms and a lot of different interpretations and opinions on each of these terms. And if you search for data-driven development, you'll most likely find information about what's actually really business metrics and data-driven design. So there's a big overlap between those two, as essentially the main focus there is to use data to drive the design of a product that customers will actually want to buy and use. So it's important to note the differences though, because that's going to change how you use your metrics and who is actually using those metrics internally. So business metrics, this refers to anything related internally to internally measured success. So things like team velocity, sprint burn down, lead time, etc. Business metrics, though, can also include external facing metrics. So a lot of this is what people refer to as vanity metrics, which can often include things like we're putting 3 million messages through a day. And this is typically intended for things like press releases and blog posts. Data-driven design relates specifically to the end user experience. As the name implies, the main focus here is to use data, typically data involving usage patterns or user feedback, in order to better understand and design for the needs of that particular user. Data-driven development is often either sort of lumped together with one of these or is like an umbrella term, and I do think it can still be pretty appropriate as an umbrella term, but my focus on it here in this talk is where it represents metrics that are targeted at changing the development process itself. So that's what I want to talk to you about today, because I think it's pretty essential to be able to look at this on its own in order to leverage it properly, especially for something as complex as stream processing. Secondly, there's a set of principles that come more directly from data-driven design, but they're very relevant to all these areas as well. So this is the idea of a three-tiered approach that defines the type of metrics that you use and how they guide your product, but categorized by their relationship with quantitative or qualitative data. So you have data-driven design, which is centered purely around quantitative data. This process is applicable to aspects of the software design, like optimization and performance. And as you progress outwards, you next have data-informed design, which weighs and utilizes qualitative and quantitative data equally and usually together in order to make a design decision. Furthest out, you have data-aware design, which is typically focused more on qualitative information, but quantitative analysis is still often used as a base or to pair with things like customer use stories, detailed feedback, or discussion-based risk-reward type analyses. This category is also often thought of as the one that takes the larger picture into account, which is why this diagram is also often portrayed like a circle, like this. And I really like using both diagrams. I think they both kind of give a little bit different impression. But one of the reasons I like this one specifically is that it shows that wider scope where it progressively takes in more types of data as you get further out in the circle. And I think it's also important, because this will come up later, that typically development styles in the center tend to be easier to automate, whereas the further you go outwards, the more manual the processes will have to be. Kind of, how it is. So this is also particularly relevant for how to share metrics effectively with different internal teams and groups as you get closer or further out from the engineering team that's at the center, which we found for stream processing actually tended to be kind of a big deal. So lastly, a little bit of a short review of stream processing before we really jump into it. So a lot of you are probably familiar with streaming, so I'll go through it super fast. But if you are familiar, feel free to just tune out for the next 90 seconds or so. If you're not, hopefully this can help you get a little bit of a start. So as the name implies, stream processing involves a continuous stream of data. This is used primarily as a distinction from batch processing, where data is published to a system or application in bounded units or batches. So nowadays, this is actually slightly more complicated because frameworks like Apache Flink and Beam now offer a unified API in order to seamlessly kind of switch between batch and stream processing. And we like to say that this essentially is treating batch as like a special type of streaming. But they can still be pretty clearly and separately defined in this way, at least. With a continuous stream of data, there's a lot of benefits. Most data is actually already best collected this way, which is one of the reasons we like to define batch as kind of a special case of streaming, since streaming tends to be a little bit more natural. So great examples of this can be input from a video game, weather sensor readings, or customer usage patterns. So without breaks and having to wait for new batches, it just naturally has more potential for fast data transfer, better real-time analyses and processing, and having lower latency. So as for what this actually looks like, with most stream processing frameworks, at the one end, you can ingest data from a variety of sources, which produce the events, like these on the left here, and at the other end of your stream, most frameworks will allow you to publish data to different types of sinks, like a data store, various types of storage, or even to another data stream, like any of these here on the right. In between's the fun part. So typically, data from one or multiple of these sources is written either to a log or another data stream or a message queue like a Kafka or Pulsar topic. And then you have your actual stream processing application. So using a framework like Apache Flink or Spark or Storm, or there's a whole variety of others. So as you can see in this diagram, some stream processing frameworks are paired with local or occasionally external storage that enables the current application state to be stored regularly, similar to like a snapshotting system. So again, this little database here, this is not going to be the case for all stream processing frameworks. So this is referred to as stateful stream processing. And this will look a little bit different depending on which framework you're using. Spark, for instance, distributes the state into a cluster and does most of the management of it. Samza replicates state across multiple machines. Generally though, and on a pretty high level, being stateful means better fault tolerance as it can be used for updates or rollbacks in case of issues or outages, and it can also be used for A/B testing and working in parallel with different versions. So it can be pretty handy. Flink uses a checkpointing mechanism where checkpoints are created regularly for a specific duration or at specific durations along the stream, and the current state of each task is copied after all tasks have processed the same input. And in case of an outage or any other killed process, there's other mechanisms to restart that whole application. And then before the tasks are started again, they're reset to that latest checkpoint. So frameworks like Flink also allow for querying the application state. So as you see, that's what the little query sign there is for. Okay, so now you're all stream processing experts. We've covered the event producers on the far left over here, or sources. We've covered the queue going down the line here, or the log or initial data stream, the actual streaming application, and then the sink where the data is eventually served up or published to. And for any of you that were tuning out who were already familiar with stream processing, feel free to come back in. So the challenge here is with a system like this is that you're now ingesting unbounded streams of data, and you're regularly storing that state, the state of an application that is continuously consuming possibly massive amounts of data. It never stops, or at least ideally, it really shouldn't. You really hope it won't. So all the benefits of stream processing, being able to push through huge amounts of data and doing it super fast, all of this have what are probably some fairly obvious impacts on anything downstream of your application and anything related to storage along that stream. Additionally, you could have a streaming application that consumes data directly from an initial source, but it's much more likely that the data that you're consuming into your streaming application has already undergone probably multiple transformations already, possibly gone through several other applications depending on your whole technical ecosystem. It's also pretty likely that your application is consuming multiple data streams, and maybe even having to merge them. So this means you could be consuming data in multiple formats, or have very different throughput rates. And it's extremely likely that your application will need to publish data to multiple different sinks. This is a very common stream processing scenario, although full coordination with upstream and downstream teams, particularly in relation to metrics, is often very overlooked, which is why I want to talk about this. So overall, the biggest challenge with this type of architecture is that relationship between an application in the situation with the technical ecosystem around it, and just how much different that is when that's a streaming application. Those integration points, they become much more complex, and I'll be getting into that a bit later, specifically about structuring metrics around those points, how to keep those metrics meaningful without a lot of hassle, and how to tend to the fact that multiple different groups and teams might be sharing any one integration point. And that brings us to metrics-driven metrics. How do you measure to know, what do you measure to know what to start measuring? I know, right? And where do you get started? How do you know what the right metrics are? So first though, you really do have to start somewhere. So on that most basic level, of course, the best start is always keeping it really simple. So whether that's a proof of concept or a playground application that mimics production, just starting that small cycle and growing that with the growth of your application's development. But in addition, whichever framework you choose, so whichever stream processing framework you're using, it's going to have its own recommendations for specific key components to measure, and most of them have really good documentation for this, so that's fairly straightforward. However, within this, it's pretty easy to get lulled into just measuring what's recommended, which is where these data-driven development practices really come in. So later, I'll have some examples of situations where this whole metrics-driven metric cycle has really drastically altered how we measure certain components. and even how we change who owns these components as well. So that's kind of why I want to really nail down these concepts, since they're going to give you a leg up for being able to stay flexible when your stream processing application inevitably becomes complicated and maybe just a little bit weird. So this dashboard specifically is a really great example of labeling exactly what's important to track, and includes a pretty full list of which metrics to start with for our example framework here, Flink. And most of these components have equivalents in other frameworks as well. And I'm also using this dashboard here because this provider does an exceptional job of really explicitly labeling what's important to track in this. Like I actually literally had a list of what I wanted and I was going to make my own, and then I found this one and it was exactly that. So thank you, Internet. Thank you, Datadog, for this one. And as I mentioned, so the UI dashboard that's included with Apache Flink, it already has a lot of this information. So that includes how many jobs are running, restarts, task manager count, etc. And on my last engineering team, we decided that separating out the application status by using the Flink UI and our own monitoring platform separately was much more of a time saver for us. So we use the Flink UI as part of our deployment process as well. So for many people, especially if you share your dashboard with other teams, it can be useful to kind of have them together like these people did here though. So in summary, really using both of those can help get you a much stronger, more robust monitoring system. And just to give you a visual of that, so this is what the Flink UI options look like. The top is the basic one that just comes with Flink out of the box, and below is the Ververica platform. So I picked the community edition because it's free, and the platform also has a link to the traditional out of the box Flink UI. So if you're like me and you love metrics within metrics, then that's all these here together, which is great. And as you can see, both have everything that you saw in that left-hand column in the previous slide, plus more. So all of this is related to the status of your application. And again, as I mentioned, it can still be really helpful to combine these with additional metrics providers so you can leverage the strength of both of those platforms. So secondly, going back to this diagram, another thing I really like about this dashboard is that you can see several different complementary pieces of your checkpointing in one place. So for instance here, failed checkpoints as a single number is pretty useful, and that's a pretty typical thing to measure. But combining that with the last checkpoint completion over the span of at least several hours, this is a lot more impactful because you're getting that really granular look with a little bit of a better overview. And then next, resource utilization, seen here in the right column. This is especially useful for Flink as a lot of the operations are dependent on the JVM heap, depending on how you configure it, but for the most part, yeah. So however, resource management for any stream processing framework is of course going to be pretty important because the higher impact a memory leak would have for a continuous stream of data is much higher. And I'll cover some of those metrics like throughput later on. And in terms of actually getting these set up, so as I said, Flink has reporters that allow internal metrics to be exposed externally to specific providers. This is all pretty straightforward through a YAML file that comes with the out-of-the-box Flink. You can also configure multiple reporters, and each job and each task manager gets instantiated with those reporters when it started. So it's a really nice, just kind of built-in system. So I provided, these are examples of the Prometheus and Datadog reporters. So note, if you're using Prometheus though, Flink also has a reporter for a push gateway that can be scraped specifically by Prometheus. It's a little bit more complicated than this one, which is the more direct kind of vanilla Prometheus that we have here. And it's not really recommended for all use cases, but I'll have a link to that in the end. So if anyone's interested in learning more about that, it's pretty interesting. So additional configurations that can be made internally depend on the specific provider reporter. So for instance, you can configure the intervals at which reports are sent out, but it's only allowed for certain providers. So there's just some interesting things there as well, also in the documentation. And it's also possible to create your own or to use providers that Flink does not have a reporter for. Really, they just have to be in a jar that contains that reporter, and that's placed in a specific folder, and Flink will be able to find it. So it's still pretty easy to even just to use the things that are not just available by default. So beyond all those specific components that you want to measure for stream processing and specifically with Flink, when it comes to knowing where to start and what metrics are going to be really valuable to you, I found that trying to have a single answer to that question is just really ineffective. So instead, I was much more successful once I started framing this as a process, kind of this ongoing iterative practice of really knowing your normal. And I'm really thankful for a teammate of mine that really honed this into our team, and I feel like my whole team will forever old team that's no longer existing, but everyone who's on it will forever be very cognizant of how important it is to know your normal. So the main components of this that I found are super simple. Focus on what's meaningful, staying iterative, and keeping things accessible. So as for keeping your metrics meaningful, starting with some really good basic dashboard hygiene goes a shockingly long way in enabling a process that can help you keep those metrics really meaningful. So firstly, your dashboard should reflect the values and development priorities for the application that you're monitoring. This probably sounds really obvious and kind of generic, but I want to emphasize just how important this was for us and how much this enabled us to just keep our velocity going, and development was just so much smoother with this. And this was something that with our non-streaming applications, we could just sort of loosely adhere to that philosophy and it just sort of didn't matter. But with stream processing and with something as powerful as Flink, because those extra complications and impact, we found this was much more essential. So I'll get into that in a moment too. So on this previous engineering team I was on, this was actually our actual dashboard. And I love this dashboard because it really is a great example of one that's curated to really have the metrics that were actually the most important to the engineers that really were driving the development process for that specific application right on top. So there were a lot more metrics below. This is actually only like half the dashboard, but we were very selective about what went on top. So although we're also flexible, so if the top engineering priorities changed, so did the dashboard. And this usually just meant swapping out one chart for one that was maybe further down the list, and when it was time to focus on that specific feature. And this just became a normal habit, a normal part of our stand-up and our roadmap work, which just made things so much easier. It's basically automated. So for this particular Flink application, the consumption from our Kafka topics and our watermarks, even just a sampling of them, were particularly valuable, at least at this point in the development of the application. And I just want to keep saying that this whole, it all has to be iterative, like just keeping it really specific to what is important at that point in development. So watermarks in Flink and in some other frameworks like Apache Spark, this is a mechanism for controlling the duration of time where an application will wait for a record to arrive. So this feature has many applications, and it's the basis for most event time operators. Watermarks often help determine how late records are handled, meaning that this could have a pretty big impact on whether, what order, and how data is ingested into the stream. So it's important, but it's also something that's usually just like an estimated guess, designated by the engineer or engineering team. So for this reason, it was really, really essential for us, at least in this early developmental part of the application, to keep an incredibly close eye on our watermarks, because this was likely a configuration that would need to be adjusted a lot as we got more information about the data coming through. Next, each of our incoming data streams had its own lag chart for the Kafka queue. So by taking some initial measurements of data flow and looking at the structure of the output, we were able to determine that some of our upstream teams aggregated and transformed data very differently than how we expected, and it actually even differed by team. So how this helped drive our development, though, was that once these metrics were in place and we had a better understanding of just how differently the data was handled between these upstream teams, it naturally guided a restructuring of ownership. The information almost automatically completely redefined responsibility for integration points in a way that was based now on the behavior of the software itself, which was much more efficient than how it had been structured previously before we had this information. So next, throughput and checkpoint size were the next priority. Throughput should hopefully be a pretty obvious one. You want to have a good handle on how much data is coming through your stream. So we had our throughput separated out by which source the data originated from, which enabled us to have an overall view of throughput throughout the whole system, but also allowed us to click into a specific upstream application when needed. We also tracked our throughputs at each reduce function throughout the whole streaming application, which really gave a really nice insight into that whole pipeline. As I mentioned earlier, checkpoints, or in general, for any stateful stream processing application, anything that's related to how your state is stored, this impacts so many essential parts of your streaming application. So it should be pretty clear to your engineering team that they should maybe be pretty familiar with what's normal and abnormal for this component for your application. This dashboard, however, has actually a very unusual way of tracking checkpoints. So that brings us to keeping the process iterative. So it's much more common in Flink to track the number of checkpoints, usually for a certain duration like within the last hour, or for any anomalies over a longer period of time like a day. However, for our team here, at this point in the application's development, we were under certain restrictions for how we wrote data out to our syncs, and some syncs still needed to consume on a once daily cadence, because we're working with some streaming and batch applications that we had to integrate in. So for this, we focused on the checkpoint size, which should follow a predictable pattern of steady growth and a single once-a-day drop, again, in this particular weird case. So here, an abnormal drop or spike could mean that we were losing state, or that, in one case, there was a mismatch in how incoming data from different sources were being timestamped. Overall, instead of being completely stuck on textbook metrics, although that's a great place to start, it was so much more effective and really a lifesaver for this application to stay as flexible as we could. So it was important to allow the data that we're receiving about our system, along with any information we had on our weird and unique situation, again being data informed here, going back to that circle diagram in the beginning, to guide our modifications to our metrics, even if it meant monitoring in really non-traditional ways. So again, this is that metrics-driven metrics cycle. Okay, so you have a dashboard, it's got meaningful prioritized metrics, it supports iteration and flexibility, right? Yep, looks good. So check, but they also have to be something that's easy to use. So particularly if you're sharing it, or if you get paged at 3 in the morning and you need to very quickly make sense of all these pretty lines and colors. And there's a lot of different techniques on this, but honestly, the most helpful thing that I found is really just thinking about scale. So because having the right things in the right order will definitely help with ease of use, but prioritizing a list of 1,000 items is still 1,000 items. And that brings us to accessibility and the actual practice part of that metrics-driven development. There's a lot of resources about how to be intentional with what to measure and why and where you put it. And I just have a couple favorite quotes on this, which is Harvard Business Review saying, "It is simple enough to describe how to inject data into a decision-making process. It is far harder to make this normal, even automatic for employees, a shift in mindset that presents a daunting challenge." Or more simply, a Tech Beacon article that reminds us you can measure almost anything, but you cannot pay attention to everything, which I both love and hate because I want to measure everything. I feel like I need this like emblazoned on my desk because I definitely need to remind myself of that a lot. However, my favorite quote on this is actually from another engineer that I was talking to about this recently, who said that in any situation where people create their own dashboards without structure, will quickly start to look like the cockpit of a 747. And I love this quote because it just brings you this really great image of what an anti-pattern this is. So I think we've probably all, or most of us, have seen dashboards that kind of look like this at one job or another. So this is my opportunity to just say, nope, just your PSA for nope on this one. Okay, so with that very important PSA, we can move on to metrics as a shared language. So there's another Harvard Business Review article saying the biggest obstacles to creating data-based businesses are not technical, they are cultural. But more specifically, I like to think of this as even the best data-driven development fails easily when it's only built for yourself. This fact is something that we could basically ignore with a lot of our non-streaming applications on my last engineering team. But as I mentioned with stream processing, and again with really powerful ones like Flink, the integration points are just so much more complicated, and you're going to have a different relationship with your upstream and downstream applications and teams. So firstly is knowing how to use your metrics as a shared language to enable smoother communication. It's also about understanding the language and preferred tools of your audience within that community. And this is not really a particularly new thought. There are lots of companies that have successfully integrated the idea into their company culture of treating internal users the same as external customers, at least to some degree. However, it's not often extended to those who don't really use your service, but who share integration points or resources or who are upstream of you. So even if your company already has good practices around internal customers, I think it's at least worth thinking outside the box for kind of defining who uses your service and who's impacted in that larger sense as well. Usually, particularly as an individual contributor, you likely don't really have to think about this a lot, and most companies, particularly the larger they are, already have probably tons of processes set in place for cross-team and cross-organization communication. However, when building and integrating a new streaming application, I found that these processes were not enough. With our first streaming application, we found that people from all over the company suddenly needed a lot more information. And explaining the same stream processing and Flink concepts, re-explaining our streaming specific alerts, and being included in incident responses that seemed kind of far from our domain all suddenly became a big part of our development process. So some of these groups, like other engineering teams, needed the same granularity that we did, but filtered differently. Other groups needed to be able to pivot between summary and depth, and still other groups needed full abstraction. And I like this diagram because it shows and delineates these groups, but also provides a spectrum of most technical to most abstract. The group at the top needs the most in-depth technical coverage, because that's you. If you're an engineer listening to this talk, it depends on who you are on this scale here. And as you get further out, the information and the way of sharing it become more and more abstracted, as I said. This seems kind of complicated, but once we understood this, we began to be much more intentional with how and who we shared information with along that development process. And I found it was actually easier to get this process automated once we understood this, and then we didn't have to really think about it or deal with it as much, which was really great. So starting at the center here, monitoring for yourself. This is probably the monitoring that we think about the most, because let's be honest, this also may be the only monitoring we're thinking about. And we've basically already covered this. This is all about where to start specifically with monitoring for stream processing. This is about creating a practice of meaningful, iterative, and accessible metrics. So then going further out, we knew that if everyone was looking at the same initial metrics, no one would get the information that was useful to them, even other engineers. There had to be some type of filtering or abstraction, but it really didn't need to be complicated. Most of this revolved around a few very basic data-driven concepts, including just keeping our alerts in small modular units and using the same language and tools of our intended audience. In the end, for this group, it was the super simple solution of just relabeling our alerts and monitoring with the tag for the specific team it would impact, using Slack integration for PagerDuty, Jenkins, etc., and our monitoring providers, routing only the alerts that pertain to a specific team to a Slack channel that only had that team in it. Although we tried things that were much more complicated and were way more fun to program and way less fun to use, this ridiculously simple method scaled better than all of that, and we were able to actually keep up with any new complexity in our downstream ecosystem with very minimal effort from us. It was very much a one-time thing. I think it took like 45 minutes. So I want to give another example about this kind of additional impact of stream processing on these upstream applications and downstream applications. So this is a slice from that earlier dashboard showing the Kafka lag in data coming through from each of our upstream streams, streaming Kafka topics. So initially, we were alerting on any spike in lag over a certain threshold. This threshold had made sense to us in the context of our data pipeline and was very well thought out and based on the behavior of the majority of the streams that we were consuming. So there was actually many more streams coming in than just these three. However, in this example, using metrics as a shared language, we were able to not only determine issues that did not and may not have ever come up verbally in meetings with these other teams, and we're able to hone in on what's normal for our upstream teams, which drastically changed our alerting system. For example, the spike here at 9:10 to 9:15 is actually normal and expected for all three of these products, based on how and when these three all receive their data throughout the day. Communicating via metrics that were easily accessible and readable by all impacted teams, it was much easier to determine a more accurate threshold and to compensate for normal daily spikes. It would have been a huge pain to get alerted on this every day for three separate products at 9:10 a.m., especially if this had actually been at like midnight. So this would have been abnormal for all of our other incoming streams, but because of how and when these particular ones published their data to us, this was their normal. So knowing this normal really helped us streamline this and compensate for that in our alerting, saving us a lot of time. But of course, there's some gotchas. So anytime you're working around a daily spike or drop that's really nice and predictable, particularly for upstream teams that may be using batch processing, being aware of whether those upstream teams decide to change their data collection or publishing schedule is very important. Or worse, it turns out that autonomous teams don't always have to base their event time processing in the same time zone as each other. So you could have one team using UTC and one using, say, a time zone that handles daylight savings completely differently, like PST, and you could very suddenly not be tracking or compensating for the right spikes and drops anymore. And at best, this means you get paid for something that's actually normal, but at worst, your really nice custom metrics begin to work against you. So this is so much more important while we're also working from home now too, because using metrics like this can really greatly decrease the amount of miscommunications that are just so prevalent in companies that have only recently switched to work from home and are really still adjusting. So overall, this example where enabling metrics to continuously guide how we measure and alert on our data, particularly around integration points, is so helpful for anyone that's going to be sharing that integration point. This next level is where we start to get into abstraction challenges. Leadership and internal stakeholders often need to be able to pivot between summary and depth when it comes to metrics. So this may seem like it should not be your responsibility as an engineer, but as I said earlier, we were surprised at how suddenly and intensely this became part of our process, at least initially. So the best trick that I have for this, again, is just using the language and tools of the intended audience, which really saved us a huge amount of time. So as Noshnika Fee, a fellow developer advocate here, said to me recently, the further you get from engineering, the more your status needs URL, and you'd be surprised at how far that gets you. And I've had a lot of success with that as well, particularly with something just like a blog post with language catered to that audience, but with embedding a few automatically updated charts into the post. So you set it once, and then you don't need to worry about it again, which is great, because you gotta automate that. Okay, so this last one, I'm not going to really get into as much. It's kind of on this other extreme because honestly, at most organizations, this level is officially abstracted away from your metric cycle. And I don't want to leave it out though, because we probably shouldn't forget about these people either. They're probably kind of important. So with that, we've covered using metrics to drive your development process for stream processing by knowing your normal, by keeping your metrics meaningful, iterative, and accessible. We've also covered using metrics to minimize some of those human challenges that come with stream processing that are there because of its very unique impact on the rest of your technical ecosystem. And specifically here, we talked about how to automate filtering and abstracting metrics in a way that work for different groups of people and who share those integration points, keeping it simple with techniques like small modular units and using the tools of your intended audience to really just automate that. So with that, thank you all so much for coming. Huge thank you to DataCon LA team. Really thrilled to be here, and I hope to see you all in person someday. And a huge thanks to all of the people who helped out with this as well. And I've got some of these resources, and again, feel free to reach out to me if you have any other questions about that. Thanks.